Good morning, students. Today I am going to solve a problem. The problem comes under the category of Virial equation. The problem is calculate the molar volume and compressibility factor. Calculate the molar volume and the compressibility factor for methanol vapor at 500 degree Kelvin and 10 bar using the following truncated form of Virial equation. Virial equation. Z is equal to PV by RT is equal to 1 plus B by B plus C by B square. This is the truncated form of Virial equation. The Virial coefficients B and C are given. The experimental values of Virial coefficients B and C are given in the problem. Minus 2.19 to the power of minus 4 meter cube per mole. Similarly, C is equal to minus of 1.73 to the power of minus 8 meter cube per mole. Now I am going to solve the problem in order to estimate the molar volume of methanol vapor. Okay, what is that main equation? Truncated form of Virial equation. Truncated form of Virial equation. Z is equal to PV by RT, that is equal to 1 plus B divided by B plus C divided by B square. Now I am going to substitute all the values. Clear? From this equation I am going to calculate the molar volume V. V is equal to R into T divided by P into 1 plus B divided by V plus C divided by V square. This is the final equation which we are going to use to solve the problem. So V is equal to, substitute R is equal to 8.314 Newton meter per mole degree Kelvin, joules per mole degree Kelvin, into temperature 500 degree Kelvin, divided by pressure P is equal to 10 bar. I have to substitute pressure in terms of Newton per meter square, hence 10 into 10 to the power of 5 Newton per meter square. Clear? Next, 1 plus, already B is minus, directly I am going to substitute the minus sign, minus 2.19 into 10 to the power of minus 4 divided by V. The unit of 2.19 into 10 to the power of minus 4 is meter cube per mole, divided by V. V is again meter cube per mole, unit gets cancelled. Okay, minus C divided by V square. C 1 minus 1.73 into 10 to the power of minus 8 divided by V square. The unit of C is meter power 6 per mole square divided by meter cube per mole the whole square. Again units are gets cancelled. Clear? Now all the values are substituted. Come to here. Kelvin gets cancelled. Newton gets cancelled. The remaining thing is meter square. It will be in the numerator, meter cube per mole. This unit is meter cube per mole. This is the unit of molar volume. Now I am going to substitute all the values. Already all the values are substituted. I am going to solve the problem. 8.314 into 500 divided by 10 into 10 to the power of 5. Okay. Use the calculator. What is the value? 4.157 into 10 to the power of minus 3 into 1 minus 2.19 into 10 to the power of minus 4 divided by V minus 1.73 into 10 to the power of minus 8 divided by V square. The value of molar volume of methanol vapor can be calculated by using trial and error value. Now substitute a value of V here and find the molar volume. If substituted value and predicted value are equal, then your substituted value is correct. To begin this calculation, substitute this volume by using ideal gas law. So V is equal to P RT by P. Already we substituted 8.314 into 500 divided by pressure 10 into 10 to the power of 5. The answer is 4.157 into 10 to the power of minus 4. Substitute this value in the right hand side B. To begin the problem, substitute this value in the right hand side B. Okay. Just a minute. That is V is equal to 4.157 into 10 to the power of minus 4, 1 minus 2.19 into 10 to the power of minus 4 divided by this value 4.157 into 10 to the power of minus 3 minus, what is the value? 1.73 into 10 to the power of minus 8 divided by 4.157 into 10 to the power of minus 3. Okay, now I got the value of 3.934 into 10 to the power of minus 3. The substituted value is 4.157 into 10 to the power of minus 3. The predicted value is 3.934 into 10 to the power of minus 3. There is a difference between substituted and predicted. Hence, I have to go for one more trial. Again, V is equal to 4.157 into 10 to the power of minus 4, 1 minus 2.19 into 10 to the power of minus 4 divided by, now instead of 4.157, I am going to substitute this value. Here. That means 3.934 into 10 to the power of minus 3 minus of 1.73 into 10 to the power of minus 8 divided by 4.157 into 10 to the power of minus 3. Are you clear? Now the substituted value is 3.934 into 10 to the power of minus 3. What about the predicted value? The predicted value is 3.921 into 10 to the power of minus 3. Clear? The predicted value is 3.934. This is 3.921. Second decimal, third decimal deviation. Hence, I am going to go for one more trial. Now again, V is equal to 4.157 into 10 to the power of minus 4 into 1 minus 2.19 into 10 to the power of minus 4 divided by, now I am going to substitute new value here, 3.921 into 10 to the power of minus 3 minus of 1.73 into 10 to the power of minus 8 divided by 3.921 into 10 to the power of minus 3. Okay. Now predicted value is 3.920 into 10 to the power of minus 3 meter cube per mole. Hence, the substituted value 3.921 into 10 to the power of minus 3 and predicted value 3.920 into 10 to the power of minus 3. It is almost closer to each other. Hence, I am decided that this is the molar volume of methanol vapor at a temperature of 500 degrees Celsius, 500 degree Kelvin at 10 bar. This is the molar volume V. Next, I am going to calculate the compressibility factor Z. Compressibility factor Z. Z is equal to PV by R into T. That is equal to P in terms of Newton per meter square. 10 into 10 to the power of 5 Newton per meter square. Newton per meter square into volume. Just now I predicted 3.920. 3.920 into 10 to the power of minus 3 meter cube per mole divided by R. 8.314 joule per mole degree Kelvin. I am going to write Newton meter mole degree Kelvin. And temperature is 500 degree Kelvin. Temperature is 500 degree Kelvin. Okay, Newton gets cancelled. Mole gets cancelled. Kelvin gets cancelled. Meter square meter cube term, only meter gets cancelled. The answer is compressibility factor Z equal to 0.943. Compressibility factor Z is equal to 0.943 for methanol vapor. Okay, thank you.